Hey guys, today we are going to evaluate some more logarithms without always having to use a variable. Okay, so we'll do a little review. Log form versus exponent form. So in exponent form, you've got a base to an exponent equals an argument. In log form, it's log, a base, argument equals the exponent. So a logarithm is asking what power or what exponent raises this base to equal this argument. So what's being asked here is what power raises 5 to make 125? Or 5 to what power makes 125? So I wrote this with a variable, but we don't necessarily need one. 5 to what power makes 125? That would be 5 to the third power. Okay, so the value is 3. The next one is asking 3 to what power makes 1? Well, anything to the 0 power makes 1. Okay, so next is 8 to what power makes 2. For this one, let's try a variable. 8 to what power equals 2. If I put both of these in the same base, both sides in the same base, I'll be able to find out. So 8 is the same as 2 to the third power. So I'm going to change this 8 to the x to 2 to the 3x. Because 2 to the third power is 8. And this side is 2 to the first power. Now that they have the same base, the exponents are equal. 3x equals 1, so x equals 1/3. (27) to what power makes 1/9? I think this is another one that's easier to visualize if we set it equal to x and write it as an exponent. 27 to the x power equals 1/9. 27 to what power makes 1/9? So I want to try to get these two in the same base. I could do a base of 3. 27 is 3 to the third power, so that is 3 to the 3x power. Let's space that out a little better. And 1/9, 9 is 3 to the second power, so 1/9 is 3 to the -2 power. So I get 3x equals -2. Bases are the same, therefore the exponents are equal. So x is -2/3. So sometimes it's going to be easier to use a variable, sometimes it's going to be pretty easy not to use a variable. Here the question being asked is what power raises 5 to make 5 to the third power? 5 to what power makes 5 to the third power? That would be 5 to the third power makes 5 to the third power. 4 to what power makes 4 to the -2 power? 4 to the -2 power makes 4 to the -2 power. B to what power makes b to the x power? B to the x power makes b to the x power. Okay, now if I had written this in exponent form, I would have b to the x equals b to the x. So it's the x power that raises b to make b to the x. What power makes 9 to the 1/2 power? Or 9 to what power makes 9 to the 1/2 power? 1/2. 2 to what power makes 16? 2 to the 4th power makes 16. 9 to what power makes 3? This one might not be so obvious, so let's do this with a variable. 9 to the x power makes 3. So I can change this 9 into 3 squared, so it's going to be 3 to the 2x power equals 3, and that's 3 to the first power. Equal bases means equal exponents. 2x equals 1, so x is 1/2. So 9 to the 1/2 power makes 3. 3 to what power makes 1 over 81? So the first thing we need to think of is 3 to what power makes 81. Forget about the 1 over 81. 3 to what power makes 81? So we've got 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 to the 4th power makes 81, which means 3 to the negative 4th power makes 1 over 81. 1/3 to what power makes 27? So let's pretend that's not a fraction for now and just do 3 to what power makes 27? 3 times 3 is 9, times 3 is 27. So 3 to the 3rd makes 27. So 1/3 to the negative 3rd makes 27. Point 1 to what power makes 1,000? Okay, so that 0.1 is the same as 1/10. So log base 1/10 of 1,000. 1/10 to what power makes 1,000? So let's just pretend it's a 10 here instead of a 1/10. 10 times 10 is 100, times 10 is 1,000. So 10 to the 3rd power is 1,000, which means 1/10 to the 3rd power is, or to the negative 3rd power is 1,000. 1/10 to the negative 3rd power makes 1,000. Okay, now this next one's a little bit different. 3 raised to whatever power raises 3 to make 7. The answer is going to be 7, but we just need to think about what that question is asking. 3 raised to whatever power, because this log, the value of this is a power. 3 raised to whatever power raises 3 to make 7. If I raise 3 to that power, I'm going to get 7. Or, if we want, we could turn that into equals x and make this a logarithm. Log base 3 of x equals the exponent log base 3 of 7. Same base, same argument. X equals 7. B raised to whatever power raises b to make a. The answer is going to be a, but let's put it in log form. So we'll set that equal to x. Log base b of x equals log base b of a. Same base, same argument. X equals a. So our answer is a. So log base 4 of 1/16. So 4 to what power makes 1/16? Well, 4 to the 2nd power makes 16. So 4 to the negative 2nd power makes 1/16. And 57 raised to whatever power raises 57 to make 21. The answer is going to be 21. But let's set that equal to x and put it in log form. Log base 57 of x equals the exponent, which is log base 57 of 21. Same base, same argument. X equals 21.